Okay. What? Okay. There we go. Whew. All right. All right. Sorry about that, y'all. Hopefully this is going to help out with the buffering. I can't make any guarantees. Things are still a little bit experimental right now, but yeah. Good. All right. I'm just going to move us on. Give me a thumbs up in the thread if you can hear me, if it's stable and okay on your end. There's a, like I said, there's a 30-second additional latency now, so yeah, I'll just keep us moving on. All right. All right then, that's good. Let's move on to copying a dictionary. It's kind of funny. I don't know how to solve this problem subtractively without copying. I don't know how to do it well, at least, so without weird side effects is what I'm saying. Or at all. Yeah. Anyways. Cool. So let's look at copying. Copying, this gets into that whole issue of mutability, which I think I just kind of covered fairly well, but the reason we'll just do a little microcosm experiment of what we were just looking at, just to have a clear idea. Let's see if I can grab that car dictionary really quick. We'll just start with this one. Okay, so let's say I have some dictionary and I pass it to def some function, takes in some dictionary, and it will say d sub something equals something else. Okay, so I've got my data, I've got my function. Function doesn't return anything. I'll say some function takes in d, and I'm just going to print d before and after the function, and hopefully this will make it even extra clearer if it wasn't clear before. So notice I'm printing the dictionary. I'm not printing in the function. I'm not returning anything from the function. I'm not printing the result of the function. I could, but oops, wrong hotkey there. I could print like I could print this, but we're just going to see none since this function doesn't have a given return. It has a return value of none. It has a value of none, so it's not really important to see that. So all that's happening here is we're just printing off the dictionary before we hand it to the function and printing off the dictionary after we hand it to the function. Again, and this is what I was just going over, I think, before I had to restart stream. This is an anti-pattern, what we call an anti-pattern. It's something to be avoided at every possible opportunity. If you find yourself thinking, oh no, I really do need to mutate the input here, just stop what you're doing, go take a breather, don't do anything you might regret. Just stop what you're doing and think, do I really need to mutate the input? Is it actually essential, or is there a way around that I can get around doing that? So, and there is, which is, oops, And I'm just using a global variable here, which is amazing. Anyways, that's what I meant to be doing. That's another thing that you should avoid as well. But yeah. So you don't want to mutate the input directly. The right thing to do is sum d equals sum d dot copy. So this is usually what I'll do. I'll usually just override the same variable name with a copy of itself. That way, for the whole rest of the function, I don't even have access to the original to screw it up. And in most circumstances, this is fine. In this remove approach, it actually was kind of advantageous. And I'll just copy and paste this down real quick. It actually is kind of advantageous to have a different name, right? So rather than doing imp d equals imp d dot copy, I am saying d, which is a different name, and I'm doing that way I can iterate through a different object than I'm removing from. If I did imp d here, and then remove from imp d, then I would need to copy again. And this is like, there's something very, very safe about this approach, but I don't want to do this because I have the footprint of the original dictionary in my program's memory, the copy of the dictionary that I intend to remove from, so I've doubled the footprint, and then the copy of the one that I intend to iterate through. So I've tripled the footprint of this data essentially, just for one function. So it's somewhat unavoidable. If you're going to do this safely, it's unavoidable to have some duplication. The solution that had the least duplication was the additive solution. So again, that's why that's preferable. But if you are going to do the subtractive solution, then doubling the data is the least amount of duplication that you can get away with, that I know of. Maybe there's some other obvious or not obvious way of doing that, but that's what comes to my mind when I'm looking at that. So sometimes it's useful to copy this under a different name. Usually, like I said, I'll just override the same name. That way I don't even give myself the opportunity to mess up the original. And then if at some point I realize, it would be useful to have a second copy, then I might come back here and then rename this. That way I don't have to triple the data, I can just double it. Okay, so all that to say, now if we do this, now this function is safe. It's safe meaning that we pass in an object to it and it will not mutate its inputs. So this section is in learn is about copy, the copy method, obviously, and this is the reason to use it. So you don't end up altering something that you don't want to alter, right? Now, of course, if we were going to make this function useful, we'd return some d like that. And then we could print it off. And then we'd have our modified version without modifying the original version. Cool. Okay. So let's just jump in straight into the challenges. Why do you think you shouldn't just use dict copy equals d syntax? This is actually important. I should cover this. Like, why wouldn't we use this? Like, why can't I just do like d copy equals sum d, like just give it a different name. And you can think about, what's this going to do? spacing this out because I'm nothing to do. So what is this going to do? So essentially, this might look like it's going to create a copy, but what it actually does is it creates a different identifier and points it at exactly the same object. So you have one object in memory with not one, but two different identifiers pointing at it. So here's your dictionary, and then here's identifier 1, and then here's identifier 2, both pointing at the same, plugged into the same dictionary. So it's one object that has two different names. This is also to be avoided. I can't honestly think of a good reason other than to like give something like a semantic context. But you should probably think of one good name rather than two good names. If you have to if you have to rename something for the sake of it being semantic in one context but not semantic in another context, you could probably think of a better name for it initially, right? You probably should have given it a better name when you started. But yeah, I basically can't think of a reason to really justify doing this. It doesn't really make sense. So this is one of those things that Python just lets you do anyways. It's like, okay, you're going to have two identifiers for one object. So that's why we want to avoid that, because this is a false copy essentially. And let's run this and prove it, right? We can see now the result after we pass it to the function is that it's been mutated. So this is a false copy. Sometimes this is called a shallow copy. I don't really like that term because it's not a copy. It's not a copy at all. It's just two identifiers pointing at one object. So, okay. Why should we avoid that? Because we just told you to do. Because I just said so. Because everything that you read online about programming is right. Because it's about a technical subject. Because I imagine that's supposed to read so, because doing so would only copy the keys. Nope, that's not true. Because it's got to be this one. Because doing so results in two different variables, and I'm saying the word identifiers, but same difference. Two different variables referencing the same object. Recall that an object is a section of memory that holds the values, and therefore changing that object using one variable would change the same object associated with the other variable as well, since they are literally the same object just with two names. Yes, so it's that last one. All right. What will be printed from the two print statements? So we've got, let's see, dict1 equals dict2, and then the IDs. So we're going to see if the values are equal, true or false, and if the IDs are equal, true or false. So let's see. 1, 1, 2, 2, 3, 3, 4, 4. Good. Then we say d.copy. Okay, so their values or their IDs are not going to be equal, since I see dict2 dot copy their IDs, which is the ID of the object in memory, the numeric ID given by the system or by the Python interpreter in memory. So this is going to be false. And then we're saying dict1 sub 5 equals 5, dict2 first, dict1 second. But yeah, we're performing the same mutation on both of them, and they started off the same because we're copying them. So their values will be identical, but their IDs will be different. So that should be true, false. Yeah. All right. In the code block below, do the following steps. So use only the assignment operator equals to assign the contents of the person1 dictionary to the variable called person2. Do not use copy. Oof. Add the keys. Okay. All right, I'll write it below. Person 2 equals person 1. It feels unnatural to do this. I'm like looking at it. I'm like, it's not right. I gotta change it. Okay. All right. I'll just let it go though. I'll have to find a way. Add a key called job status to person 2. Okay. Job status to the person 2 dictionary and set the value to true. Person 2 equals sub job status. Okay, I'll keep the single quotes. Equals true. Use .copy method to make a copy of the person 1 dictionary in a variable called person 3. Person 3 equals person 1 .copy. Delete job status from person 3. Del person 3 sub job status. Okay, did that do it? Correct. Yay, I did it. Awesome. All right, seems like the signal, I'm just going to do a quick check on the signal if it's holding. Seems like the stream is holding pretty well. All right, good. Yeah, if anybody's got questions, feel free to throw them in. And if not, we'll just continue on with dictionary accumulators here. All right, so by the end of this lesson, you'll be able to implement the accumulator pattern with a dictionary, understand how different dictionary values can be set to different objects. Okay, so I already showed, I would call either of these solutions accumulation solutions, even though one is decrementing and one is accumulating. I will tend to call both of them accumulators. So this is actually a great example of a simple dictionary accumulator. Actually, let me just, I'll copy the whole thing. Just delete the subtractive solution because I don't like it. All right. So accumulator pattern, regardless of what the type is, simple basic accumulator pattern is going to be, we start with an empty dictionary, or we start with an empty or zeroed out, empty or zeroed out accumulator target, run it through a loop. Probably we check condition that tells us when or how to alter it. In this case, we just have one condition and one alteration. Our loop can contain potentially one or as many accumulators as we need. So I could accumulate, and actually the subtractive solution accumulated into a list, as well as decrementing. So it was accumulating, it was doing a positive accumulation onto a list, and it was decrementing the keys from the dictionary. That's another, little bit of memory overhead in that subtractive solution. We have to have that list. Yeah, so basically that's it in a nutshell. This just describes a really simple accumulator. So with dictionaries, things can feel like they get a little hairy at times. I would call this kind of a pure accumulator pattern, because we just, like I said, we start with an empty dictionary and then we accumulate key value pairs. But there's a few variations, and this is partly why we will tend to talk about accumulators in the context of the type being accumulated on. We'll tend to say like a list accumulator or a numeric accumulator, because it kind of tells you what kind of structures you might expect. And the overall structure is usually always the same, more or less, but the each type may or may not have like different kind of facets, different things that are a bit unique to it, right? So this is just a basic, simple one, just a little bit of everything, not too complicated. Oops. Let's look at a different one. I'll do a little, this is why I have this text in here, actually. Just basically for this problem. I like to do this problem as an exercise with students. When I do one-on-ones, if I show a solution here, we could still probably do it and it'd be fine. Okay, so what I want to do here is I just have a little bit of text, and actually go back to the big text, and I want to build a dictionary that's going to go through here and make keys out of the words, and the values are going to be the number of times that word occurs in this text. Right? So let's call this word frequency. I'll make my test first, word frequency dictionary. We'll take in text. I'll just call this txt. And we'll iterate through it. We'll say for word. And now I want to turn the text into a list of words, so I'll say txt.split. And just to prove that that does what I said it was going to do, which is turn it into a list of words, let's just print word real quick. Why do I feel like I've got invalid syntax somewhere? Parent. I was just like, I know there's an error somewhere. Okay, alright, well, it's not where I thought it was, but... Okay, cool. So here is just each word printed out, right? Whose, woods, these are, I think I know, so dot split, if I don't pass it, a parameter is going to split on spaces. It's actually going to split on all new line, or all white space characters. So there are several white space characters, or there's two. There's new lines, which are these characters that I'm currently putting in, the carriage return characters. And then obviously there's space characters, right? And these are just characters. To us, they look like nothing, but to the computer, they are every bit as much character as any other character, right? As W or S or whatever. So if I don't pass split anything, it's going to split on all white space characters, which means basically if I call it on a string of like a body of text, I'm going to get words. So that's pretty convenient. And this text has been cleaned of parentheses. I could make it lower also by doing dot lower, and that'll be all lowercase. Okay, so for word, and we'll just print it off again just to prove that we have all lowercase. You can see I is now all lowercase. So for word in text.lower.split. Remember, I'm trying to end up with a dictionary of, let's write a schema for this so it'll be easier to remember what we're trying to end up with. So it'll be a string containing the word, and then an int representing the frequency. So an int representing the frequency of that word. Okay. So def word frequency dict for word in text.lower.split print word. Okay. So let's make an accumulator because that's what this is about. I'll say d. Oh, come on. D equals empty dictionary. And then now I want to say if word not in d.keys. The astute among you may know that keys is not necessary here. I can just check D. And this is usually how you'll see that, but I like to be explicit, especially for presentation purposes. Like, like we are definitely checking keys, not key value pairs. So even though that's not necessary, it's just to make it clear. So if word is not in the keys of the dictionary, then I want to add D sub word, and we'll start it at 0. And then we'll say D sub word plus equals plus gets 1. We'll increment it by 1. And what this does is it makes sure that D sub word is in the dictionary before we cause the alteration to it, right? There's multiple ways of doing this. We could have an else branch here, and then if we do that, we need to start this at 1 since we're not going to increment, right? This is saying we're either going to initialize or we're going to increment something that already exists. We could also do if word in d.keys, but then we need to switch these. If word is in d.keys, we'll increment, else we'll initialize with 1, and in this case we could also have word out here initialized as 1. But the way I like to do it is if word not in d.keys, initialize with the value of 1 or of 0, and then increment it. And basically this is like saying, hey, I want to increment d sub word by 1, but first, in order to do that, I have to tell Python to put d sub word in the dictionary. And yeah, so this is my preferred way of doing it, just because that's the way I think about it, but you can do it. There's a number of ways. But basically, it's check to see if your target is a member of the keys, and if it's not, add it in, and if it is, then increment your target. And I'm calling it a target because essentially this is d sub word. This perhaps may look reminiscent of an integer accumulator, right? This is like saying some word equals 0, and then some word plus equals 1, right? So this is basically an accumulation, right? An integer accumulation, but we're just storing those different targets for each word in a different key in the dictionary. So yeah. Okay. That's what's happening there. So this is kind of a funny thing. It's a pattern that's really common with dictionaries. You can think about this essentially as a dual accumulator, and we'll look at a different version of this, or a different style of dictionary accumulator. What should I call it? Different form of dictionary accumulator that has a bit of a different application that hopefully will make this kind of thing a little more obvious. But essentially, we have a double accumulator. We have an empty dictionary that we're accumulating key value pairs into, but we're also accumulating onto the values of those keys, right? So we initialize the key value pair. This is the accumulation into the dictionary. And then this is the accumulation onto each key value pair. So let's see what we get. There, that's what we get. Cool. And obviously that's kind of a lot of output, but you can see, whose appears once, Woods appears 4 times, these appears once, R twice, etc. I 5 times. Now, again, the astute among you may realize I don't need to do any of this. I can just say d sub word equals, this would be, let's do this, lst equals this, lst.count word, and then we don't need any of this, right? So there is a way of doing this problem where we don't need to do that style of accumulation, but this is the problem that I had preloaded, so deal with it. There are times when that kind of accumulation is necessary. For example, maybe if I wanted to do instead of integers, maybe I wanted to do lists dot append. Maybe I want to append the index that I find each word at. I'll get the index from enumerate, idx, and word. This is word indices dict now. I'll just give it a better name, right? So now we have a bit of a different dictionary. I'll paste this in. Actually, why don't I do this? Why don't I print it off in a more sensible way? So we'll say for k v in word indices dict dot items print, and we'll do an f string k colon, yeah, oh, v, yeah, we'll do that. Okay. So you can see now I have the keys are the words and the values are a list of the all the indices where that word occurred. So, and in this case, I can't, I don't have a way to get around that, with that a nice dot count thing that'll just give me a list of all the indices. I kind of have to do this little bit of a juggle right here with if we're not in d.keys, right? So this is a pretty common pattern where you are accumulating. Essentially, you can think about dictionary accumulators in 2 forms. One is where you're accumulating onto the dictionary itself, and one is where you're accumulating onto the keys. And then there's sort of a third form, which is both, and this is both. We're accumulating into an empty dictionary. Obviously, we're accumulating key value pairs, and we're accumulating onto the values at the keys themselves. So we start with an empty list and then accumulate into that list. That's an example there. And then let's look at the other form in sort of a pure state. I don't have a preloaded example for this. I'll do this again. There's a breakout problem. If you're in Premium Prep, you'll probably remember this one. So let's say I have a dictionary with predefined categories. And I want to make some observations about some body of text. Oh God, what should I call this function? I should make a function. Let's just call it text data dict, and it'll take in text, and we'll do that. And then make our test. Actually, I'll copy my testing schematic here. Okay. 4KB, okay, that should be good. And then let's just have some categories. Let's say, let's get a different version. I have a version of this this text with punctuation in it, so it'll give us something to bounce off of here. Okay. So let's say punctuation. Punctuation characters. We'll start it at 0. And then let's have lower. Lower for lowercase, upper for uppercase, numbers, something like that. We'll just do this. And you can see, I'm essentially, this is similar to if I had, oops. Imagine I had 4 variables like this. It's just that these variables are bound up in a dictionary together where they belong, right? Because now I can have one data type that kind of tells me everything I need to know. So in this case, to me, it's obvious that I'm probably not going to be accumulating new key value pairs into the dictionary as much as accumulating onto the keys that already are in there. So, that's better. Okay, so let's see. So for, let's say C for character in text, if C dot is upper, I think is upper. I might have to Python 3. I'm just going to do dir of string really quick. Where's my is space, is numeric, is lower. Aha. Oh, interesting. I don't appear to have an is upper, but I do have an is alpha. Okay, so I'll do is alpha. I have is alpha and is lower, so is alpha. So if C is alpha, I know I'm going to accumulate into one of these two. And then also we have spaces. That's another thing. So if C dot is alpha, now I can say if C dot is lower, D sub lower plus equals 1. else upper plus equals 1. So I don't really need to go through and like all of this, but really I just wanted to get the kind of get the point across, right? You will see, oops, of course my code is not running right now. Oh, turn D. There we go. Okay. So we counted 401 lowercase characters and 21 uppercase characters. I don't know. Perhaps I might be doing something wrong or something. I'm not sure if that's accurate. It seems feasible to me, so we'll just go with that. But yeah, without necessarily going through all of this, the pattern that I want to demonstrate here is this sort of predefined categories. So this is another form of dictionary accumulator that you'll see, and it's a little bit of a false dictionary accumulator because it's really the accumulator type of whatever the values are. So if the values in this case are integers, they're going to be integers. You know, and maybe I want to have multiples, right? Maybe I want to have you know, maybe I want this to be a list of indices where all the punctuation characters occur, right? Maybe I want this to be like the sum of the, well, I guess if I wanted it to be the sum of all the numbers, it would still be a numeric accumulator, right? Maybe I want this to be a string containing all the spaces. I don't know why I would want that, but who knows? So I could have different kinds of accumulator targets in the dictionary. And again, it's just like as if I were creating variables to do the same thing. Oops. Yeah, you get the picture. If I were just creating variables like that, you know, you wouldn't have a hard time like saying, oh, I just need to accumulate into the correct variable. It's exactly the same thing. It just happens to be that instead of variables, these are keys that are bound together in a dictionary. So you can think about it like that, and that's a pretty dang useful working analogy. Obviously not 100% the same, but you know, you need to know how to access the key with the dictionary syntax like this, but you know, essentially that's a way of thinking about it. So yeah, I would think about, to me, I think about this as like predefined categories, style accumulation dictionary, and then versus the other one, which maybe we could call this a pure dictionary accumulator because we're actually starting with an empty dictionary and accumulating key value pairs into it. This is a hybrid because we're actually doing both. We're accumulating key value pairs and we're accumulating onto those key value pairs. So actually we've got one of each, right? So delete dups is a pure dictionary accumulator. Start with an empty dictionary, and all we do is accumulate key value pairs under the right circumstances. Here's a hybrid one. The word frequency or the word indices dict is a hybrid one because we're accumulating key value pairs and we're accumulating onto the key value pairs. And here's a purely categorical style where we have predefined keys and we just accumulate onto those keys directly without adding new keys into the dictionary. So it's useful to kind of for me, it was useful to kind of break those out into like two or three predefined categories, however you want to think about it. And then aside from that, there aren't like other major forms that you might find showing up in dictionary accumulation. So, yep. All right. We've got a couple minutes left, but I'm thinking that's probably good. I wouldn't mind picking back up on dictionary accumulators again and kind of even just revisiting some of this stuff, because accumulation is so central to the way we teach problem solving in programming, and dictionaries are a bit of a complicated type, so I think giving them extra airtime, it won't hurt anything. So we'll probably just pick this back up, and I'll do like a shortened version of talking about accumulators next time as well, and then I'll do the challenges. For anybody who's still around, DM me if you don't mind. Let me know if the quality was okay, if the audio is all right. Like I said, I'm making pretty heavy changes to the streaming setup, so it's still a bit experimental. I anticipate that I'll still need to dial things in over the next few streams until it's really nice. But let me know if it's, because I know the streaming quality has been low on prior streams, but let me know if this is causing latency issues or anything else, any other helpful feedback you feel like sharing. I am open to. I'm sorry we didn't get any questions today, but perhaps next time do feel free to bring this in. I hope I didn't make it seem too intimidating or like there were too many rules. Also don't mind just keeping it casual. And just bring in your questions. Whatever you want to talk about is fine. Cool. Right. I'm feeling myself repeating myself at this point. So I'll wrap up there. Look forward to next time. Next stream will be on Friday. And I'll see y'all around. Bye-bye.